Okay, this is the answer key for the acceleration formative assessment. Again, as you're correcting, you need to make sure any mistakes that you make are corrected on yours in order to qualify to take the retake. So problem 1, it asks you, says during a race, a sprinter increases from 5 meters per second to 7.5 meters per second over a period of 1.25 seconds. What is the sprinter's average acceleration during this period? On this problem, we've already given you the equation right here that acceleration is equal to final velocity minus initial velocity divided by time. And we've even given you some of the values here, what final velocity is, what initial velocity is, what time is. So now it's basically just plugging in information into the equation. So acceleration is equal to final velocity, that would be 7.5 meters per second, minus the initial velocity, which would be 5.0 meters per second, divided by the time of 1.25 seconds. So once I plug the information into my equation, I can do my math. 7.5 minus 5 would be 2.5 meters per second, divided by the time of 1.25 seconds. Run that through your calculator. I get 2. My units will be meters over seconds. And remember that the seconds down here actually comes up and is multiplied. So I have seconds squared. So the acceleration would be equal to 2 meters per second squared. On problem number 2, it says a runner went from 6 meters per second to 2 meters per second in 2 seconds. What is his acceleration? And again, on this problem, we're still giving you the equation, so you don't even have to bother looking on your note card. But we didn't plug in any information on to the left over here, so we have to find it. So remember, the final velocity is the last recorded speed. So in this case, it would be 2 meters per second. The initial velocity would be the first recorded speed, so this would be 6 meters per second. Time would be 2 seconds, and now I need to run my equation to solve for acceleration. So again, we have acceleration is equal to final velocity, which would be 2 meters per second, minus the initial 6 meters per second, divided by the time of 2 seconds. So 2 minus 6 would be a negative 4 meters per second, still divided by the time of 2 seconds. So a negative 4 divided by 2 would be a negative 2. We have meters per second here. And again, remember that this second moves up and is multiplied by the other second, so we have a squared second. My acceleration is a minus 2 meters per second squared. This is also called deceleration because it means that it slowed down. And it does say, it implies that the runner went from a high speed to a slow speed, so you'd get a negative. And you can get negative acceleration values, and we call those deceleration. Okay, on this problem, number 3, it says a dog runs with an initial velocity of 1.5 meters per second on a waxed floor. It slides to a stop with an acceleration of negative 0.35 meters per second squared. How long does it take for the dog to stop? So this one we don't give you an equation, and long here is implying time. So we know that time, according to our equation card, is final velocity minus the initial velocity divided by the acceleration. Now remember, final velocity is the last recorded speed. Well, it doesn't really tell you the speed here, but you kind of got to infer that since it says it stops, that means its last recorded speed would be 0. And we're in meters per second units, so it would be 0 meters per second minus the initial velocity, which was 1.5 meters per second, and the time that it takes to change is a negative 0.35 meters per second squared. That's the acceleration. You can always identify acceleration because it has that squared time unit. So now that I do my math, 0 minus 1.5 is a negative 1.5 meters per second divided by a negative 0.35 meters per second squared. So numerically, a negative divided by a negative is going to come out to be a positive. When I run it through my calculator, I get 4.29, but now I need to figure out my units. Well, this meter will divide with this meter. And one of these seconds in the squared acceleration unit will divide out with that one, and the other second then moves up and becomes the unit. And since we're solving for time, time is measured in seconds. Remember, time can't come out negative, so if it does, you've made a mistake somewhere in your problem. On the last problem here, number 4, it says if a Ferrari with an initial velocity of 10 meters per second accelerates at a rate of 50 meters per second squared for 3 seconds, what will be its final velocity? So we're solving for final velocity. So from our equation card, we know that final velocity is equal to the time times the acceleration, and I always put that in parentheses so I know to do it together, plus the initial velocity, VI. So when I start plugging in my information here, the time that it takes to change is 3 seconds times the acceleration of 50 meters per second squared, and again that's in parentheses, plus the initial velocity of 10 meters per second. When I do my math now, 3 times 50 is 150, but now my units are going to be the following. This second is going to divide with that second, one of the squared seconds, so that will come out to be meters per second. And we have the other plus 10 more meters per second, which would give me a grand total of 160 meters per second. So my final velocity would go from 10 meters per second after 3 seconds of that acceleration. The Ferrari would go in 160 meters per second. So again, your corrections should be made. You can turn this quiz in to get the retake and see if you can get the magic number of 4.